get an semaphore signal. On these two data structures, we are applying three types of operation. First one is the initialization of semaphore, second one is increment, and third one is a decrement. So these are the three operations which are performed on a semaphore. Now in general example, what is actual semaphore? Suppose I explain you the your example of your railway track. So what is here? When your track is a railway and track, so this track is nothing but the resource required by the railway. So whenever the track will be allocated by the train. So this is what initialization means. That train is allocating this railway track. Now it has been allocated, so it will send which signal? Semaphore wait. So second train cannot travel on that track. So semaphore wait. At this time it will increment. It will decrement the value. It will decrement the value. And when it finished the execution, means the train is released that track. At that time, it will send semaphore signal operation. That means it will increment the value. So this is the use of semaphore. Okay. So semaphore, a variable that has an integer value upon which only three operations can be performed, or three operations can be done. There is no way to inspect or manipulate semaphore other than these three operations. Only these three operations can be performed on a semaphore. First one, which one? May be initialized to a non-negative integer value. So initialization of a semaphore, the value should be non-negative. Second one is your semaphore wait. Semaphore wait operation that will decrement the value. And third one is a semaphore signal operation that will increment the value. Okay. So there is no way to know before a process decrement a semaphore whether it will be blocked or not. So what happens here? There will be no way to know the process decrement a semaphore whether it is blocked or not. Then there is no way to know which process will continue immediately on the uniprocessor system when two processes are running concurrently. So these are some consequences regarding to the semaphore. Means what happens here? If two processes are running simultaneously in uniprocessor, we cannot find means which process is there on that rail line, or we can say which process is executing. So it cannot be found out. You don't know whether another process is waiting. So number of unblocked process may be 0 or 1. Means that train is traveling on the track. It does not know whether there are another trains that want to travel on this track. So this is not known by that process. So these are some consequences in a semaphore. So now listen here. Can you see this code? Okay. So what is here? Structure semaphore. Then we have specified the variable in integer, count, and queue type is nothing but the queue. Now there are two operations. Listen here. These are the main. Means which is here semaphore wait, and second one is a semaphore signal. So here we are initialize semaphore. That is initialization of semaphore is a count initialization, and second one is a means a semaphore wait, in which we are specifying semaphore as a yes object. Semaphore object is yes here. Now listen here. When it is allocating, h dot count is equal to minus minus, means it is decrement. It is decrement. Means this resource has been allocated by the process. If h dot count is less than 0, what happens? Place this process in a h dot queue and block this process. Means this process have finished the execution. Okay, it will release the resource. Now semaphore signal check h dot count plus plus here, because here decrement, here it is increment. Initialization, increment, and decrement are the operation performed on the semaphore. So here now it is which one? Count plus plus. If count dot h dot count is less than equal to 0, remove the process P from the queue. It will be allocated and place process P in a ready queue. Now this process will be ready for execution. We will allocate the resource. So this is how semaphore will execute. I got this one. I got this code. Decrement. It will be decrement, and when it release the resource, at that time it will increment operation. So three operations are performed: initialization, increment, and decrement. So decrement, allocation. In simple language, what we can say, whenever the train will allocate that track. So what will here? Semaphore is object, semaphore object count minus minus. If s dot count is less than 0, place this process in a ready. Means what happens? We have finished this execution of this process, block this process, execution is finished. So now in this semaphore signal, it will release the resource, which will release resource. Second process can allocate the resource. So what is giving here? S count plus plus increment operation. If s dot count is less than equal to 0, remove the process P from queue, s dot queue, and place that process in a ready queue. Now this process is ready to execute on a or allocate the resource and execute. Okay. So that is the use of semaphore, definition of semaphore primitives. Now binary semaphore. Binary means only two values, 0 and 1. So here we are specifying the binary semaphore. Again, here 0 or 1. Enum 0 or 1. So 0 and 1. 1 is allocated, 0 is not allocated value. So semaphore wait, binary semaphore yes. Now here if s dot value is equal to 1, s dot value is equal to assign 0. Means what happens here? Else this place is in a SQ, means this process is allocated. Tumsa process has been allocated because s dot value is equal to what? 1. Now when it will release, so it will set 0. So signal, semaphore signal, if s dot q is empty, means what happens here? No process is executing on the processor. At that time it is empty. So it will checking what? S dot q is what here? Empty. It will set the value to 1, means that will allocate that resource. Now it is ready to execute. Else remove the process from p dot s dot q, place process in a ready queue. Alek lakshat, 1 asanta it is allocated, 0 asanta not allocated in simple language. So it is what? Binary semaphore. The third one is your strong semaphore and weak semaphore. How many types of semaphore are there? 4 types. First one was the general semaphore. Second one was the binary semaphore, in which it is setting zeros and 1. Value 1 allocated, 0 release the resource. So, and third one is which now? Strong semaphore and weak semaphore. So what is strong semaphore? A queue is used to hold the process waiting on a semaphore. So in that strong semaphore, the process that has been blocked the longest is released from the queue first. That is called as a strong semaphore. The process which is waiting for semaphore for longer time, okay, that process is released from the queue first using first in first out method. That type of semaphore is called as a strong semaphore. And weak semaphore, the order in which process are removed from the queue is not specified. Means any process can be removed from the queue and allocate the resource. So that is called as a weak semaphore. The order is not followed. While in the strong semaphore, the block process, a process that is waiting for more time, that process is released first using FIFO, first in, first out. That is called as a strong semaphore. So these are the 4 types of semaphore. So here is an example of semaphore mechanism. So here S is equal to 1. Okay. S is equal to 1. So here is what? Ready queue, and here is your block queue. So whenever this S is equal to 1, so it will go into the रेडी क्यू. दिसतंय का? ब्लॉक क्यू मध्ये तुमची प्रोसेस नाही. इट विल गो इनटू द AC specified, so it will go into the ready queue. So here is your ready queue. So how many processes are there in ready queue now? CDB. So one by one the process will be allocated to the processor. The issue semaphore now here it will specify. It will issue a semaphore wait. Later timeout means that second process, third process cannot enter the or not allocate the resource. If A is executing, so 3 will be in a waiting state. Whenever it is finished the execution, it will send the signal. So this is first one. Now this is a block queue. This one is block queue. S is equal, semaphore is equal to 0. Semaphore is equal to S is equal to 0. Here the process are ready. C is executing. C issues semaphore wait. Okay. So it will be in a block queue now. Okay, got this first one. असन तर त्याच्यामध्ये नसन तर तो ब्लॉक क्यू मध्ये. Not executing, it will go into the block queue. Then again, here now this example, semaphore, yes, ready queue, CB. Now second one, B will execute. B issues semaphore wait. Likewise, D and remaining process will be executing in a semaphore. Now, how mutual exclusion is carried out using semaphore? So you know what is mutual exclusion. Only one process is allocated to enter the critical section. Now listen here, program mutual exclusion. So how many const integer n is equal to number of process. Suppose 5 ABC, 5 process, A, B, C, D, E, 5 process are there. Now semaphore S is initialized to 1. Okay, semaphore S is initialized to 1. Now process, which process? Integer I. Now which process it is? While the condition is true. So here is what? Semaphore wait. Alek lakshat, semaphore wait. Now in a critical section. It will execute in a critical section. Resource has been allocated. It will execute. Then semaphore signal. तुमचं execution झालंय. So it will set what? Semaphore signal. Now second can and the remaining code will execute. In simple language, means that process want to allocate the resource. So what will be the hit? It set semaphore wait. And when it finish the execution, it will set semaphore signal. So these are the two data structures, semaphore wait and semaphore signal. It want to allocate, it will set semaphore wait. When it want to release, semaphore signal. So what will happen? Second process, it will check whether it is semaphore wait or semaphore signal. Suppose it is semaphore signal, then it will allocate the resource and it will set semaphore wait. When it is finished, again it will set semaphore signal. Likewise, all process will executing. So here is main begin P1, P2 and Pn process will execute. I got this one. What is use of semaphore wait and semaphore signal? I have got this one main. अरे काहीतरी बोला रे. लक्षात आलं का हे semaphore? ओके, सोप्या भाषेत तुम्हाला सांगतो म्हणजे काय तुमचं ट्रेन वॉन्ट टू ट्रॅव्हल ऑन अ ट्रॅक. सो मग जेव्हा ट्रेन ॲलोकेट करीन ट्रॅकला त्यावेळेस तो काय सेंड करेन सेमॅफोर वेट आणि इट विल एक्झिक्यूट. आणि ज्याचा जर ट्रेनचा ट्रॅक त्याने रिलीज केला ऍट दॅट टाइम इट विल सेंड सेमॅफोर सिग्नल. नाउ सेकंड ट्रेन वॉन्ट टू ॲलोकेट द ट्रॅक सो इट विल चेक व्हॉट वेदर इट इज सेमॅफोर वेट ऑर सेमॅफोर सिग्नल. जर सेमॅफोर वेट असेल तर थांबून जाईल. इफ यू गेट सेमॅफोर सिग्नल means what the track is free and it will allocate that track and it will set now semaphore wait. So that second process cannot enter the critical section. This is how they are mutual exclusion is handled using semaphore. Okay. So here this is the same process access share data protected by semaphore. So here value of semaphore lock 1 semaphore wait. Okay, म्हणजे तुमचा A is allocating. A is in a critical section. So normal execution. So semaphore wait, then log that. Then the value semaphore will be, means here will be at 0. Okay. Then second B minus 1. Here is how much now? Minus 2. Again from this 1 execute. Again it will become minus 1. Okay, इथं 2 आहे ना minus 0 पासून इथं काहीच नव्हतं सध्या. मग B minus 1 minus 2 decrement operation. Then again here is increment because one has B is executing. Then 0, no one is executing, so 1 is released. So process access share data protected by SEMAPHOR. ठीक है, लक्षात लग SEMAPHOR. And second one was your mutex. Mutex is same as SEMAPHOR, but it is having only one value. Okay, either 0 or either 1. So that is called as a mutex. Again, it is performing mutex lock, mutex unlock, same as a SEMAPHOR. How about this one? SEMAPHOR. Okay, now next part is your classical synchronization problem. Classical synchronization problem. In that first one is your producer consumer. Then second one is your reader writer, and third one is a dining philosopher. And third part was your monitors. तर हे आपण उद्या घेऊ आता. लक्षात आलं का? Means your which part is remaining was classical synchronization problem. That is second part of your unit number 3rd, and third part is your deadlock. So in first part only one point is remaining, that is your monitor, programming based system. In that it is nothing but the monitor. So we'll start this monitor in a tomorrow's lecture, Mondayच्या lectureला. Have you got this one?
Yes, sir.
बाकीचं आपलं काय काय झालं आता? What is mutual exclusion? What are the condition requirement for mutual exclusion? How to handle the mutual exclusion? In that there are 3 types. First one is a hardware based, second one is a operating system based, and third one is your programming based. In the hardware based, again 2 types. Then in the operating system support based, 2 types, mutex and SEMAPHOR. And in the programming based, it is a monitor. So remaining is your monitor. So in monitor will start on the Monday, and then the second part will be your classical synchronization problem. So that is producer, consumer, reader, writer, and dining philosopher. This part we will take on a Monday's lecture. Okay. And second unit notes, first unit notes पाहिले का सगळ्यांनी?
हो सर.
कळतं काही त्याच्यामध्ये? पाहिले म्हणजे वाचले की एखादा पॉइंट त्याच्यातला?
हो.
सगळ्यांनी यास नो पाहिले पण दिलेल्या नोट्स त्या? सेकंड युनिटचे नोट्स मी देतो तुम्हाला संध्याकाळपर्यंत. ओके. काय अडचण आहे की इथपर्यंत? अडीच युनिट, अडीच म्हणजे 2.33 युनिट. एनी डिफिकल्टी? सगळ्यांना सगळं कळतंय मला वाटतं. का कोणाच काय? मंगेश जाधव. मंगेश. ठीक आहे, सोमवारच्या लेक्चर पाहू आपण मॉनिटर्स अँड देन विल गो फॉर क्लासिकल सिंक्रोनायझेशन प्रॉब्लेम. मंगेश झोपला का काय?
नाही सर, बोला ना, येतो आवाज.
मंडेच्या लेक्चर विल गो फॉर मॉनिटर्स अँड क्लासिकल सिंक्रोनायझेशन प्रॉब्लेम. मी तुम्हाला संध्याकाळी सेकंड युनिटच्या नोट्स देतो. जमलं तर वाचा, वेळ असेल तर. ठीक आहे. We'll see on, we'll meet on Monday's lecture at 11 o'clock. Okay.